Hello, welcome to my video on 4.5 Quantitative Data Analysis. Firstly, quantitative data analysis can be used for multiple things. These can include creating and/or confirming hypotheses, to assess attitudes, opinions and behaviours, and to generalise results to larger or wider populations. This means that quantitative data analysis has many benefits, such as allowing you to compare against normative data, comparing between different sports performers, for example sprinters and long distance runners, make comparisons between different populations like genders, heights or weights. As well as this, it allows you to spot trends in health and sports performance, and this allows you to make predictions about the future in sports. Now we are looking at the preparation or organisation of data. Organising data is very important, as it means that your data will be in set places and set formats, making it easier to find later on. As well as this, organising the data at the beginning makes it easier to analyse and interpret later on, saving a lot of time. One way to organise data is using a range. This is the distance between the highest and the lowest value. For example, the range between a dataset with the lowest number 1 and the highest of A would be 7. This is good as it shows the spread of data, but does not take into account any outliers. Rank order distribution is ranking the data in order from highest to lowest, or lowest to highest. This allows you to easily find the range, mode, and median. Simple frequency distribution is another way of organising data, and it shows the frequency of each score in the form of a tally or written as a number. This is good to use when there are less than 20 different scores or numbers, and the range is less than 20. If this is not the case, group frequency distribution will be used, as this shows the frequency of a group of scores. For example, how many times someone scores 10 to 15 points in a basketball game. There should not be more than 20 groups of scores or less than 10. Here are some examples of these. You can pause the video here to see this. Once you've organised data, it is important to present it in the correct format in order to make it clear what you are showing so anyone can understand it. There are many ways shown on the screen which will be described in more detail shortly. Firstly, tables are a very good starting point when presenting, as it shows exact numbers clearly and can be easily manipulated. As well as this, once you have a table, you can use this to help make all types of graphs. One of these could be a scatter plot, which is used to show a relationship or correlation between two variables. You can use regression lines on these to show trends. For example, this regression line shows a weak positive correlation. Another type of graph uses a line graph, which shows how something changes over time, and so is good when looking at differences. You can also use multiple lines in one graph, so you can show comparisons between the first set of data and the second. Also, bar charts show frequencies and can be very good for looking at differences. However, they are best to use when the independent variable is not a number, so when you're looking at different factors like colours or heights, for example. Another way to present data could be in a histogram. These will show how distributed the variables are and incorporates a group frequency distribution. In addition to this, box and whisker graphs are similar to bar charts, as again they show the frequencies or lengths. However, these are more detailed as they show more types of data like the interquartile range and the median. Data is not always distributed in the same way, but in an ideal world, all data would be normally distributed. This is where data has an even spread of values from the minimum to the maximum. They should show bell-shaped curves with 68% of the data between the first standard deviation and 96% between the second. Finally, 99% of the data should be between the third standard deviation, and it is also known as a Gaussian distribution curve. However, sometimes we get non-normally distributed data or skewed data, which is where it is not evenly spread and you don't get the bell-shaped curve. data can be negatively skewed to the left, where the median and mode will be greater than the mean, or positively skewed to the right, where the mean will be greater than the median and the mode. Outliers are also very common in datasets. These are pieces of data which don't fit the pattern or relationship that the rest of the data shows. Outliers are often removed or manipulated to fit the data. Firstly, in 1980, Hawkins decided to trim outliers by removing them from the dataset completely. However, later on, another way to do this was to Windsorrize the outliers. This is where you modify any outliers to the nearest accepted value, as shown below. For example, here 17 was not seen as an outlier, whereas 6 was, and so 6 was changed to 17, giving it another 17 value. The same goes for 38 and 25. Presenting data in the most simple and powerful way is essential, as you have to get the message across whilst making it easy to understand. To do this, we use descriptive statistics to present. These are placed under two categories. The first one is central tendencies. This shows a value to represent a set of data by finding central position. This is done with the mean, which is the most common central tendency. For example, if you've done vertical jump testing, you would do 3 attempts, add them together and divide by 3 to find the mean. Median is also used, which is the middle score in a dataset when in rank order. Finally, mode is another central tendency and is the most frequent value that occurs. So for example, in the last slide there was the outlier was changed to 17 and then there was 3 values of 17, so therefore this would have been the mode. The other category is dispersion. Dispersion shows how spread the data is, so shows you the variation of the dataset. There are also 3 measures of this, which are standard deviation, and this shows how the data is spread apart from the mean. The third bullet point on this shows how mean and standard deviation are written. Using this, you can see how spread a dataset is, even with the same mean. For example, if the standard deviation is higher, the data is more spread. The range shows the difference between the minimum and the maximum, but this includes outliers and so is not always the most reliable when it's a really spread out dataset. And the interquartile range shows the range of the middle 50% of the data, which is usually like the most relevant part of the data as it doesn't have any outliers in it. Now I'll go through some examples so you can pause the video to look at these in detail. Inferential statistics are used to show if a difference or relationship is statistically significant, or if it really matters. Therefore, we can use these to see how effective a variable is on another, and how much of a change it may make. There are many different tests which can be determined using a decision tree. This is decided whether you are comparing means or looking at relationships, what kind of variables are tested, and how many subjects/groups there are. There are two layers of analysis in inferential statistics. The first shows if there is a difference or relationship by giving a t-value for difference and a number between -1 and 1 for relationship, which may be an r value. -1 here is a negative relationship and 1 is a positive relationship. The second layer of analysis gives a p-value and tells you if the difference or relationship is statistically significant. However, if something is not statistically significant, it can still be practically significant. For example, if an energy drink helps improve sprint speed by 0.1 seconds, this may not be statistically significant, but in an elite competition, this can make all the difference. There are 5 different tests we use for this, including for testing difference, including dependent t-test, independent t-test, the Wilcoxon matched pairs signed ranks, the Mann-Whitney U, and the chi-squared test. I'm going to go through the dependent t-test and the independent t-test. The dependent t-test is used when looking at difference. Here, for GB gymnasts, thigh girth and sit and reach scores show the difference, and we can compare the t-value to 0.05 levels significance for a two-tailed hypothesis. The independent t-test is also used when looking at difference, but when samples are independent. Again, you get a t-value and compare on your critical values table to see the significance. When testing for relationship, we use the Pearson's product moment correlation coefficient, or Spearman's rank. The Pearson's correlation coefficient will produce an R value to be compared in the critical values table to see significance, and is used when the variables are interval or ratio. Spearman's rank order is used when variables are nominal and gives an RS value, meaning Spearman's rank value. This is also compared to a critical value table to see significance. For this, I used manual calculations as I did not have the software to do this automatically. However, software such as SPSS and Excel are often used to calculate this for you, especially in uni and elite labs.